Item 422. Concrete superstructures. 1. Description. Construct reinforced concrete bridge slabs, decks, flat slabs, slab and girder units, pan-formed, approach slabs, or other bridge superstructure elements as indicated. 2. Materials. 2.1 Concrete. Provide concrete conforming to Item 421, hydraulic cement concrete. Provide Class S or S, HPC, concrete for all cast-in-place concrete unless otherwise shown on the plans. Provide the class of concrete for precast components indicated on the plans or in pertinent governing items. 2.2 Reinforcing steel. Provide reinforcing steel in accordance with Item 440, reinforcement for concrete. 2.3 Structural grout. Provide grout in accordance with DMS 4675, cementitious grouts and mortars for miscellaneous applications or as indicated on the plans. 2.4 Expansion joint material. Provide materials in accordance with DMS 6310, joint sealants and fillers. Provide preformed bituminous fiber expansion joint material unless indicated otherwise. Provide a Class 4, 5, or 7 low-modulus silicone sealant unless otherwise directed. Provide asphalt board that conforms to dimensions shown on the plans. Provide rebonded neoprene filler that conforms to the dimensions shown on the plans. 2.5 Foam bedding strips for pressed rest concrete panels. Use extruded polystyrene conforming to ASTM C578, Type 5I, 40 psi compressive strength, or as specified. Provide a manufacturer's certification or data sheet stating the foam meets these requirements. Use an adhesive or bonding agent compatible with polystyrene as recommended by the polystyrene manufacturer. 2.6 Evaporation retardants. Provide evaporation retardants in accordance with DMS 4650, hydraulic cement concrete curing materials and evaporation retardants. 2.7 Curing materials. Provide membrane curing compounds in accordance with DMS 4650, hydraulic cement concrete curing materials and evaporation retardants. Provide cotton mats that consist of a filling material of cotton bat or bats, at least 12 ounces per square yard, completely covered with unzized cloth, at least 6 ounces per square yard, stitched longitudinally with continuous parallel rows of stitching spaced at less than 4 inches, or tufted both longitudinally and transversely at intervals less than 3 inches. Provide cotton mats that are free from tears and in good general condition. Provide a flap at least 6 inches wide consisting of 2 thicknesses of the covering and extending along one side of the mat. Provide polyethylene sheeting that is at least 4 mils thick and free from visible defects. Provide opaque white sheeting when the ambient temperature during curing exceeds 90 degrees Fahrenheit. Provide burlap polyethylene mats made from burlap impregnated on one side with a film of opaque white pigmented polyethylene, free from visible defects. Provide laminated mats that have at least one layer of an impervious material such as polyethylene, vinyl plastic, or other acceptable material, either as a solid sheet or impregnated into another fabric, and are free of visible defects. Provide burlap material which complies with OSHTO M182, Class 3, 10 ounces per square yard, with the following additions. Manila hemp may also be used to make burlap. Do not use burlap fabricated from bags. Do not use burlap containing any water-soluble ingredient which will retard the setting time of concrete. Provide used burlap complying with the requirements stated above, and that only has been used previously for curing concrete. Like new, cleanliness is not expected, but contamination with any substance foreign to the concrete curing process, such as grease or oil, will be cause for rejection. 2.8 Epoxy. Provide epoxy materials that conform to DMS 6100, epoxies and adhesives, unless otherwise specified. 3. Equipment. 3.1 Fogging equipment. Use fogging equipment that can apply water in a fine mist, not a spray. Produce the fog using equipment that pumps water or water and air under high pressure through a suitable atomizing nozzle. Use handheld mechanical equipment portable enough to use in the direction of any prevailing wind and adaptable for intermittent use to prevent excessive wetting of the concrete. 3.2 Transporting and placing equipment. Use appropriate transporting and placing equipment such as buckets, chutes, buggies, belt conveyors, pumps, or other equipment as necessary. Do not transport or convey concrete through equipment made of aluminum. Use carts with pneumatic tires for carting or wheeling concrete over newly placed slabs. Use tremes that are watertight to control the fall of concrete and of large enough diameter to allow the placement of the concrete but less than 14 inches in diameter. Use pumps with lines at least 5 inches inside diameter, ID, where grade 2 or smaller coarse aggregate is used, and at least 8 inches ID for grade 1 coarse aggregate. 3.3 Vibrators. Use immersion type 5 vibrators for consolidation of concrete. Provide at least one standby vibrator for emergency use. Furnish vibrator head covered by a rubberized or elastomeric cover when used near epoxy-coated reinforcing steel. 3.4 Screeds and work bridges for bridge slabs. Use a self-propelled transverse screed or a mechanical longitudinal screed for bridge slabs. Use transverse screeds that are able to follow the skew of the bridge for skews greater than 15 degrees unless otherwise approved. Equip transverse screeds with a pan float. Manually operated screeding equipment may be used if approved for top slabs of culverts, small placements, or unusual conditions. Use screeds that are rigid and heavy enough to hold true to shape and have sufficient adjustments to provide for the required camber or section. Equip the screeds, except those of the roller drum type, with metal cutting edges. Use sufficient work bridges for finishing operations for bridge slabs. Mount a carpet drag to a work bridge or a movable support system that can vary the area of carpet in contact with the concrete. Use carpet pieces long enough to cover the entire width of the placement. Splice or overlap the carpet as necessary. Ensure enough carpet is in contact longitudinally with the concrete being placed to provide the desired surface finish. Use artificial grass-type carpeting with a molded polyethylene pile face with a blade length between 5/8 and 1 inches and minimum weight of 70 ounces per square yard. Ensure the carpet has a strong, durable backing not subject to rot and the facing is adequately bonded to the backing to withstand the intended use. A burlap drag, attached to the pan float on a transverse screed, may be used instead of the carpet drag. 3.5 Temperature recording equipment. Use strip chart temperature recording devices, recording maturity meters in accordance with TEX 426A, or other approved devices that are accurate within plus or minus 2 degrees F within the range of 32 degrees Fahrenheit to 212 degrees Fahrenheit. 3.6 Artificial heating equipment. Use artificial heating equipment as necessary for maintaining the concrete temperatures as specified in section 422.4.6.11, placing concrete in cold weather. 3.7 Sawing equipment. Use sawing equipment capable of cutting grooves in completed bridge slabs and top slabs of direct traffic culverts. Provide grooves that are 1/8 to 3/16 inches deep, nominally 1/8 inches wide, and spaced at 1 inches. Use sawing equipment capable of cutting grooves in hardened concrete within 18 inches of the barrier rail or curb. 3.8 Spraying equipment. Use mechanically powered pressure sprayers with appropriate atomizing nozzles for the application of membrane curing. Mechanically driven spraying equipment, adaptable to the rail system used by the screeds, may be used for applying membrane curing to bridge slabs. Use hand pressurized spray equipment equipped with 2 or 3 fan spray nozzles if approved. Ensure the spray from each nozzle overlaps the spray from adjacent nozzles by approximately 50%. 3.9 Concrete testing equipment. Provide testing equipment for the engineer's use in accordance with section 421.3.3, testing equipment. For construction. Obtain approval for proposed construction methods before starting work. Approval of construction methods and equipment does not relieve the contractor's responsibility for safety or correctness of methods, adequacy of equipment, or completion of work in full accordance with the contract. Attend the pre-construction, pre-pour, meetings for bridge slabs conducted by the engineer. Provide and obtain approval for proposed finishing methods, interim curing methods, and final curing methods. Unless otherwise shown on the plans, it is the contractor's option to perform testing on structural concrete. Structural classes of concrete are identified in Table 8 of Section 421.4.1, Classification of Concrete Mix Designs, to determine the in situ strength to address the schedule restrictions listed below. The engineer may require the contractor to perform this testing for concrete placed in cold weather. Make enough test specimens for contractor perform testing to ensure strength requirements are met for the operations listed below. Make at least one set of test specimens for each element cast each day. Cure these specimens under the same conditions as the portion of the structure involved for all stages of construction. Ensure safe handling, curing, and storage of all test specimens. Provide testing personnel and sample and test the hardened concrete in accordance with Section 421.4.8, Sampling and Testing of Concrete. The maturity method, TX 426A, may be used for in situ strength determination for schedule restrictions if approved. Coring will not be allowed for in situ strength determination for schedule restrictions. Provide the engineer the opportunity to witness all testing operations. Report all test results to the engineer. If the contractor does not wish to perform schedule restriction testing, the engineer's 7-day lab cured tests, performed in accordance with Article 421.5, Acceptance of Concrete, will be used for schedule restriction determinations. The engineer may require additional time for strength gain to account for field curing conditions such as cold weather. 4.1 Schedule restrictions and inspection hold points. 4.1.1 Placement of superstructure members. Place or cast superstructure members after the substructure concrete has attained a compressive strength of 3000 psi. 4.1.2 Longitudinal screeding of bridge slabs. Place a longitudinal screed directly on previously placed concrete slabs to check and grade an adjacent slab only after the previously placed slab has aged at least 24 hours. Place and screed the concrete after the previously placed slabs have aged at least 48 hours. Maintain curing of the previously placed slabs during placement. 4.1.3 Staged placement of bridge slabs on continuous steel units. Ensure the previously placed concrete attains a compressive strength of 3000 psi when staged placement of a slab is required or used before placing the next stage placement. Multiple stages may be placed in a single day if approved by the engineer of record. 4.1.4 Storage of materials on the structure. Obtain approval to store materials on completed portions of a structure once a compressive strength of 3000 psi has been attained. Maintain proper curing if materials will be stored on structures before completion of curing. 4.1.5 Placement of equipment and machinery. Do not place erection equipment or machinery on the structure until the concrete has attained the design strength specified in Section 421.4.1, Classification of Concrete Mix Designs, unless otherwise approved. 4.1.6 Carting of concrete. Cart, wheel, or pump concrete over completed slabs after the completed concrete has attained a compressive strength of 3000 psi. Maintain curing during these operations. 4.1.7 Placing bridge rails. Reinforcing steel and concrete for bridge rails may be placed on bridge slabs once the slab concrete has attained a compressive strength of 3000 psi. Ensure the slab concrete has attained its design strength specified in Section 421.4.1, Classification of Concrete Mix Designs, before placing railing concrete if slip-forming methods are used for railing concrete. 4.1.8 Opening to construction traffic. Bridges may be open to all construction traffic when the design strength specified in Section 421.4.1, Classification of Concrete Mix Designs, has been attained if curing is maintained. Avoid crossing bridges at high speeds until railing concrete, if present, has attained a compressive strength of 3000 psi. 4.1.9 Opening to full traffic. Bridges may be open to the traveling public when the design strength specified in Section 421.4.1, Classification of Concrete Mixed Designs, has been attained for all structural elements including railings subject to impact from traffic and when curing has been completed for all slabs. Obtain approval before opening bridges to the traveling public. April 1, 10 Inspection hold points. Notify engineer of progress of work and when work is complete before beginning next stage of work. Beam erection and bracing. Form work, including setting of precast panels. Placing reinforcing steel. Screed dry run and pre-pour clear cover checks. Attend pre-pour meeting conducted by the engineer. Post-curing crack inspection. 4.2 Forms. Submit forming plans for decks or slabs on beams or girders, overhangs, cast-in-place spans, and bracing systems for girders when the overhang exceeds 3 feet 6 inches. Submit similar plans for other units of the superstructure as directed. Show all essential details of proposed forms and bracing. Have a licensed professional engineer design, seal, and sign these plans. Department approval is not required, but the department reserves the right to request modifications to the plans. The contractor is responsible for the adequacy of these plans. Design job fabricated form work assuming a weight of 150 pcf for concrete, and include a minimum live load allowance of 50 psf of horizontal surface of the form. Do not exceed 125% of the allowable stresses used by the department for the design of structures. Use conventional forms, permanent metal deck forms, or pressed rest concrete panels for slabs on beams or girders unless indicated otherwise. Use permanent metal deck forms or conventional forms for thickened slabs, diaphragms, or other regions as shown on the plans where pressed rest concrete panels are not used. Provide pressed rest concrete panels as shown on the plans and in accordance with item 424, precast concrete structural members, fabrication, TxDOT. Provide copies of the precast panel layout drawings from the panel fabricator. Use only material that is inert, non-biodegradable, and non-absorptive for forms to be left in place. Overhang form supports that transmit a horizontal force to a steel girder or beam or to a pressed rest concrete beam are permitted provided a satisfactory structural analysis has been made of the effect on the girder or beam as indicated in the submitted formwork plans. Use beam bracing as indicated on the plans when overhang brackets are used on pressed rest concrete beam spans with slab overhangs not exceeding 3 feet 6 inches. Provide and design additional support or bracing for the outside beams regardless of the type of beam used for spans with overhangs exceeding this amount. Attachment of forms or screed supports for bridge slabs to steel I-beams or girders may be by welding subject to the following requirements. Do not weld to tension flanges or to areas indicated on the plans. Weld in accordance with item 448, structural field welding. When setting forms of any type take into account deflections due to cast-in-place slab concrete and railing shown in the dead load deflection diagram. Differential beam or girder deflections due to skew angles and the use of certain stay-in-place slab forming systems, and deflection of the forming system due to the wet concrete. Securely stake forms to line and grade and maintain in position for bridge approach slabs. Rigidly attach inside forms for curbs to the outside forms. Construct all forms to permit their removal without marring or damaging the concrete. Clean all forms and footing areas of any extraneous matter before placing concrete. Provide openings in forms if needed for the removal of lead ants or foreign matter. Treat the facing of all forms with bond-breaking coating of composition that will not discolor or injuriously affect the concrete surface. Take care to prevent coating of the reinforcing steel. Complete all preparatory work before placing concrete. 4.2.1 Precast panels. Profile each beam to determine the actual camber or sag of the beams before placing panels. Adjust the profile grade line, panel elevation, and bearing seat elevations as needed to obtain the required cover over the slab reinforcement and slab thickness while maintaining ride quality. Make adjustments over suitable increments when a profile grade line adjustment is necessary, depending on span lengths, so the revised grade line will produce a uniform profile and good riding qualities. Obtain approval for the grade adjustments before placement. Consider actual beam camber in adjacent spans or slab placements when adjusting the grade line. Inspect each panel before being placed for cracks and other damage. Refer to section 424.4.3.1, defects and breakage, for rejection criteria due to cracking and other damage. 4.2.2 Permanent metal decking. Submit signed and sealed design calculations in addition to the required formwork drawings. Design and install formwork in accordance with the plans and formwork drawings. The plans will govern in cases where the plans and the formwork drawings conflict. 4.2.3 Conventional forms. Provide properly seasoned good quality lumber free from imperfections that would affect its strength or impair the finished surface of the concrete. Provide timber or lumber that meets or exceeds the requirements for species and grade in the submitted formwork plans. Maintain forms or form lumber that will be reused so that it stays clean and in good condition. Do not use any lumber that is split, warped, bulged, or marred or that has any defect that will produce inferior work. Remove such lumber from the work. Use plywood at least 3/4 inches thick. Use plywood for forming surfaces that remain exposed that meets the requirements for BB Pliform Class 1 or Class 1I exterior of the U.S. Department of Commerce Voluntary Product Standard PS1. Space studs and joists so that the facing form material remains in true alignment under the imposed loads. Place forms with the form panels symmetrically, long dimensions set in the same direction, for surfaces exposed to view and receiving only an ordinary surface finish as defined in section 420.4.13, ordinary surface finish. Make horizontal joints continuous. Make molding for chamfer strips or other uses of materials of a grade that will not split when nailed and can be maintained to a true line without warping. Dress wood molding on all faces. Fill forms at all sharp corners and edges with triangular chamfer strips measuring 3/4 inches on the sides unless otherwise shown on the plans. 4.3 Placing reinforcement. Place reinforcement as provided in item 440, reinforcement for concrete. Do not weld reinforcing steel supports to I-beams or girders or to reinforcing steel except where shown on the plans. 4.4 Drains. Install and construct weep holes and roadway drains as shown on the plans. 4.5 Extending existing slabs. Verify pertinent dimensions and elevations of the existing structure before ordering any required materials. 4.5.1 Removal. Remove portions of the existing structure to the lines and dimensions shown on the plans or as directed. Dispose of these materials as shown on the plans or as directed. Remove any metal railing without damaging it, and stack it neatly on the right-of-way at locations that do not interfere with traffic or construction or at locations shown on the plans. All removed metal railing remains the property of the department unless otherwise shown on the plans. Repair any portion of the remaining structure damaged as a result of the construction. Do not use explosives to remove portions of the existing structure unless approved in writing. Do not use a demolition ball, other swinging weight, or impact equipment unless shown on the plans. Use pneumatic or hydraulic tools for final removal of concrete at the break line. Use removal equipment, as approved, that will not damage the remaining concrete. 4.5.2 Reuse of removed portions of structure. Detach and remove all portions of the old structure that are to be incorporated into the extended structure to the lines and details as specified on the plans or as directed. Move the unit to be reused to the new location specified using approved methods. Place the reinforcement and extension concrete according to the plan details. 4.5.3 Breaking back bridge slabs. Saw the top surface of the slab for bridge slabs and direct traffic slabs of box culverts along the break line to a depth of 1/2 inches before breaking back. Do not cut the reinforcement at the break line. Sever the concrete at the break line. Do not damage the remaining reinforcement within 1 lap length of the brake line during removal of the designated portion of the existing structure. 4.5.4 Splicing reinforcing steel. Splice new reinforcing bars to exposed bars in the existing structure using lap splices in accordance with item 440, reinforcement for concrete, unless otherwise shown on the plans. The new reinforcing steel does not need to be tied to the existing steel where spacing or elevation does not match that of the existing steel provided the lap length is attained. Weld in accordance with item 448, structural field welding, when welded splices are permitted. Install any required dowels in accordance with section 422.4.6.10, installation of dowels and anchor bolts. 4.5.5 Concrete preparation. Roughen and clean concrete surfaces that are in contact with new construction before the placing of forms. Prepare these construction joint surfaces in accordance with section 422.4.6.7, construction joints. 4.6 Placing concrete. Do not place concrete unless approval is obtained for the hold point inspections as outlined in section 422.4.1.10, inspection hold points, and the pre-pour meeting has been conducted. Give the engineer sufficient advance notice before placing concrete in any unit of the structure to permit the final inspection of forms, reinforcing steel placement, and other preparations. Obtain approval for proposed curing methods based on forecast weather conditions for the expected duration of the pour and use the evaporation rate nomograph as mentioned below to determine the required curing options. Follow the sequence of placing concrete shown on the plans or specified. Do not place concrete when impending weather conditions would impair the quality of the finished work. Place concrete in early morning or at night or adjust the placement schedule for more favorable weather if conditions of wind, humidity, and temperature are such that concrete cannot be placed without the potential for plastic shrinkage cracking. Consult the evaporation rate nomograph in the Portland Cement Association's Design and Control of Concrete Mixtures or the evaporation rate spreadsheet available on the department's website for shrinkage cracking potential. Adequately illuminate the entire placement site when mixing, placing, and finishing concrete in non-daylight hours as approved. Furnish adequate shelter to protect the concrete against damage from rainfall or from freezing temperatures as outlined in this item if changes in weather conditions require protective measures after work starts. Continue operations during rainfall only if approved. Use protective coverings for the material stockpiles. Cover aggregate stockpiles only to the extent necessary to control the moisture conditions in the aggregates. Allow at least one curing day after the concrete has achieved initial set before placing strain on projecting reinforcement to prevent damage to the concrete. 4.6.1 Placing temperature. Place superstructure concrete only when its temperature at the time of placement is between 50 degrees Fahrenheit and 85 degrees Fahrenheit. Increase the minimum placement temperature to 60 degrees Fahrenheit if slag cement is used in the concrete. 4.6.2 Transporting time. Begin the discharge of concrete delivered in truck mixers within the times listed in Table 14 of Item 421, Hydraulic cement concrete. 4.6.3 Workability of concrete. Place concrete with a slump as specified in Section 421.4.2.5, slump. Placing concrete with slump exceeding maximum specified may result in bridge deck cracking and be subject to Section 422.4.10, defective work. Water may be added to the concrete before discharging any concrete from the truck to adjust for low slump provided the maximum mix design water-cement ratio is not exceeded. Mix concrete after introduction of any additional water or chemical admixtures in accordance with Section 421.4.6. Mixing and delivering concrete. Do not add water or chemical admixtures after any concrete has been discharged. 4.6.4 Transporting concrete. Use a method and equipment capable of maintaining the rate of placement shown on the plans or required by this item to transport concrete to the forms. Transport concrete by buckets, chutes, buggies, belt conveyors, pumps, or other methods. Protect concrete transported by conveyors from sun and wind to prevent loss of slump and workability. Shade or wrap with wet burlap pipes through which concrete is pumped as necessary to prevent loss of slump and workability. Arrange and use chutes, troughs, conveyors, or pipes so the concrete ingredients will not be separated. Terminate such equipment in vertical downspouts, when necessary, to prevent segregation. Extend open troughs and chutes, if necessary, down inside the forms or through holes left in the forms. Keep all transporting equipment clean and free from hardened concrete coatings. Discharge water used for cleaning clear of the concrete. 4.6.5 Preparation of surfaces. Thoroughly wet all forms, pressed rest concrete panels, T-beams, slab beams, and concrete box beams on which concrete is to be placed before placing concrete on them. Remove free water from the surface or beam lines before placing concrete. Provide surfaces that are in a moist, saturated surface dry condition when concrete is placed on them. Ensure the subgrade or foundation is moist before placing concrete for bridge approach slabs. 4.6.6 Expansion joints. Construct joints and devices to provide for expansion and contraction in accordance with plan details and the requirements of this section and item 454, bridge expansion joints. Prevent bridging of concrete or mortar around expansion joint material in bearings and expansion joints. Use forms adaptable to loosening or early removal in construction of all open joints and joints to be filled with expansion joint material. Loosen these forms as soon as possible after final concrete set to permit free movement of the span without requiring full form removal and avoid expansion or contraction damage to the adjacent concrete. Provide preformed fiber joint material or a high-density foam in the vertical joints of the roadway slab, curb, median, or sidewalk when the plans show a type A joint, and fill the top 1 inches with the specified joint sealing material unless noted otherwise. Install the sealer in accordance with item 438, cleaning and sealing joints, and the manufacturer's recommendations. Use light wire or nails to anchor any preformed fiber joint material to the concrete on one side of the joint. Ensure that finished joints conform to the plan details with the concrete sections completely separated by the specified opening or joint material. Remove all concrete within the joint opening soon after form removal and again where necessary after surface finishing to ensure full effectiveness of the expansion joint. 4.6.7 Construction joints. A construction joint is formed by placing plastic concrete in direct contact with concrete that has attained its initial set. Monolithic placement means the manner and sequence of concrete placing does not create a construction joint. Make construction joints of the type and at the locations shown on the plans. Do not make joints in bridge slabs not shown on the plans unless approved. Additional joints in other members are not permitted without approval. Place authorized additional joints using details equivalent to those shown on the plans for joints in similar locations. Make construction joints square and normal to the forms unless otherwise required. Use bulkheads in the forms for all vertical joints. Thoroughly clean the hardened concrete surface of all loose material, lands, dirt, and foreign matter, and saturate it with water. Remove all free water and moisten the surface before concrete or bonding grout is placed against it. Ensure the surface of the existing concrete is in a saturated surface dry, SSD, condition just before placing subsequent concrete. Pre-wet the existing concrete by ponding water on the surface for 24 hours before placing subsequent concrete. Use high-pressure water blasting to achieve SSD conditions 15 to 30 minutes before placing the concrete if ponding is not possible. An SSD condition is achieved when the surface remains damp when exposed to sunlight for 15 minutes. Draw forms tight against the existing concrete to avoid mortar loss and offsets at joints. Bonding agents are not required unless indicated otherwise. Coat the joint surface with bonding mortar, grout, epoxy, or other material as indicated on the plans or other items if a bonding agent is required. Provide type 5 epoxy per DMS 6100, epoxies and adhesives, for bonding fresh concrete to hardened concrete. Place the bonding epoxy on a clean, dry surface, and place the fresh concrete while the epoxy is still tacky. Place bonding mortar or grout on a surface that is SSD, and place the concrete before the bonding mortar or grout dries. Place other bonding agents in accordance with the manufacturer's recommendations. 4.6.8 Handling and placing. Minimize segregation of the concrete and displacement of the reinforcement when handling and placing concrete. Produce a uniform, dense, compact mass. Do not allow concrete to free fall more than 5 feet. Remove any hardened concrete splatter ahead of the plastic concrete. Fill each part of the forms by depositing concrete as near its final position as possible. Do not deposit large quantities at one point and run or work the concrete along the forms. Avoid cold joints in a monolithic placement. Sequence successive layers or adjacent portions of concrete so they can be vibrated into a homogeneous mass with the previously placed concrete before it sets. 4.6.9 Consolidation. Carefully consolidate concrete and flush mortar to the form surfaces with immersion type 5 vibrators. Do not use vibrators that operate by attachment to forms or reinforcement except where approved on steel forms. Vibrate the concrete immediately after deposit. Systematically space points of vibration to ensure complete consolidation and thorough working of the concrete around the reinforcement, embedded fixtures, and into the corners and angles of the forms. Insert the vibrator vertically where possible except for slabs where it may be inserted in a sloping or horizontal position. Vibrate the entire depth of each lift, allowing the vibrator to penetrate several inches into the preceding lift. Do not use the vibrator to move the concrete to other locations in the forms. Do not drag the vibrator through the concrete. Thoroughly consolidate concrete along construction joints by operating the vibrator along and close to but not against the joint surface. Continue the vibration until the concrete surrounding reinforcements and fixtures is completely consolidated. Hand spade or rod the concrete if necessary to ensure flushing of mortar to the surface of all forms. Concentrate vibration efforts along the beams lines when precast concrete panels are used for deck construction. April 6, 10 Installation of dowels and anchor bolts. Install dowels and anchor bolts by casting them in place or by grouting with grout, epoxy, or epoxy mortar unless noted otherwise. Form or drill holes for grouting. Use only epoxy when installing horizontal dowels into the edges of slabs. Follow the manufacturer's recommended installation procedures for pre-packaged grout or epoxy anchor systems. Test anchors if required on the plans or by other items. Drill holes for anchor bolts to accommodate the bolt embedment required by the plans. Make holes for dowels at least 12 inches deep unless otherwise shown on the plans. Make the hole diameter at least twice the dowel or bolt diameter, but the hole need not exceed the dowel or bolt diameter plus 1.5 inches when using cementitious grout or epoxy mortar. Make the hole diameter 1/16 to 1/4 inches greater than the dowel or bolt diameter when using neat epoxy unless indicated otherwise by the epoxy manufacturer. Thoroughly clean holes of all loose material, oil, grease, or other bond-breaking substance, and blow them clean with filtered compressed air. Use a wire brush followed by oil-free compressed air to remove all loose material from the holes, repeating as necessary until no more material is removed. Ensure holes are in a surface dry condition when epoxy-type materials are used and in a surface moist condition when cementitious grout is used. Develop and demonstrate for approval a procedure for cleaning and preparing the holes for installation of the dowels and anchor bolts. Completely fill the void between the hole and dowel or bolt with grouting material. Follow exactly the requirements for cleaning outlined in the product specifications for pre-packaged systems. Provide a Type 1-2 epoxy per DMS 6100, epoxies and adhesives, when neat epoxy is used for anchor bolts or dowels. Provide Type 5-3 epoxy per DMS 6100, epoxies and adhesives, when an epoxy grout is used. Provide grout, epoxy, or epoxy mortar as the binding agent unless otherwise indicated on the plans. Provide other anchor systems as required on the plans. April 6, 11 Placing concrete in cold weather. Protect concrete placed under weather conditions where weather may adversely affect results. Permission given by the engineer for placing during cold weather does not relieve the contractor of responsibility for producing concrete equal in quality to that placed under normal conditions. If concrete placed under poor conditions is unsatisfactory, remove and replace it as directed at contractor's expense. Do not place concrete in contact with any material coated with frost or with a temperature of 32 degrees Fahrenheit or lower. Do not place concrete when the ambient temperature in the shade is below 40 degrees Fahrenheit and falling unless approved. Place concrete when the ambient temperature in the shade is at least 35 degrees Fahrenheit and rising or above 40 degrees Fahrenheit. Provide and install recording thermometers, maturity meters, or other suitable temperature measuring devices to verify all concrete is effectively protected. Maintain the temperature of the top surface of bridge slabs and top slabs of direct traffic culverts at 50 degrees Fahrenheit or above for 72 hours from the time of placement and above 40 degrees Fahrenheit for an additional 72 hours. Use additional covering, insulated forms, or other means and, if necessary, supplement the covering with artificial heating. Avoid applying heat directly to concrete surfaces. Cure as specified in Section 422.4.8, final curing, during this period until all requirements for curing have been satisfied. Have on hand all necessary heating and covering material, ready for use, before permission is granted to begin placement when impending weather conditions indicate the possible need for temperature protection. Distress caused by concrete drying out as a result of delayed set and strength gain associated with cold weather are a result of the contractor's actions and are subject to repair in accordance with Section 422.4.10, defective work. April 6, 12 Placing concrete in hot weather. Use an approved Type B or D set retarding agent in all concrete for superstructures and top slabs of direct traffic culverts, except concrete containing slag cement, when the temperature of the air is above 85 degrees Fahrenheit unless otherwise directed. Keep the concrete at or below the maximum temperature at time of placement as specified above. Sprinkle and shade aggregate stockpiles or use ice, liquid nitrogen systems, or other approved methods as necessary to control the concrete temperature. April 6, 13 Placing concrete in superstructure. Place simple span bridge slabs without transverse construction joints by using either a self-propelled transverse finishing machine or a mechanical longitudinal screed unless otherwise shown on the plans. Use of manually operated screeding equipment may be permitted for small placements or for unusual conditions such as narrow widening, variable cross slopes, or transitions. Support the screed adequately on a header or rail system stable enough to withstand the longitudinal or lateral thrust of the equipment. Adjust the profile grade line as necessary to account for variations in beam camber and other factors to obtain the required slab thickness and concrete cover over the slab reinforcement. Set beams and verify their surface elevations in a sufficient number of spans so that when adjustment is necessary, the profile grade line can be adjusted over suitable increments to produce a smooth riding surface. Take dead load deflection into account in setting the grades of headers and rail systems. Use construction joints, when required or permitted for slab placements on steel or pressed rest concrete beams, as shown on the plans. Release false work under the spans before placing concrete on steel girder or truss spans, and swing the spans free on their permanent supports. Provide additional camber to offset the initial and final deflections of the span as indicated on the plans for concrete flat slab, and girder spans cast in place on false work. Provide camber of approximately 3/8 inches for 30 feet spans and 1/2 inches for 40 feet spans to offset initial and final deflections for concrete slab and girder spans using pan forms unless otherwise directed. Provide a camber of 1/8 inches for 10 feet spans but no more than 1/2 inches for concrete flat slab, and girder spans not using pan forms when dead load deflection is not shown on the plans. Provide a camber of 1/4 inches in addition to deflection for slabs without vertical curvature on steel or pressed rest concrete beams. Provide camber for specified vertical curvature and transverse slopes. Make one or more passes with the screed over the bridge slab segment before placing concrete on it to ensure proper operation and maintenance of grades and clearances. Use an approved system of checking to detect any vertical movement of the forms or false work. Maintain forms for the bottom surface of concrete slabs, girders, and overhangs to the required vertical alignment during concrete placing. Level, strike off, and screed the surface while carrying a slight excess of concrete ahead of the screed to fill all low spots as soon as the concrete has been placed and vibrated in a section wide enough to permit working. Move longitudinal screeds across the concrete with a saw-like motion while their ends rest on headers or templates set true to the roadway grade or on the adjacent finished slab. Move transverse screeds longitudinally approximately 1/5 of the drum length for each complete out and back pass of the carriage. Screed the surface of the concrete enough times and at intervals to produce a uniform surface true to grade and free of voids. Fog unformed surfaces of slab concrete in bridge slabs and in top slabs of direct traffic culverts from the time of initial strike-off of the concrete until finishing is completed and required interim curing is in place. Do not use fogging as a means to add finishing water and do not work moisture from the fog spray into the fresh concrete. Retard the concrete for simple spans only if necessary to complete finishing operations or as required by the section. Bring the top of curb and sidewalk section to the correct camber and alignment when filling curb forms, and finish them as described in this item. 4.6.13.1 Transverse Screeding. Install rails for transverse finishing machines that are supported from the beams or girders so the supports may be removed without damage to the slab. Prevent bonding between removable supports and the concrete in an acceptable manner. Do not allow rail support parts that remain embedded in the slab to project above the upper mat of reinforcing steel. Rail or screed supports attached to I-beams or girders are subject to the requirements of this item. Place concrete at a minimum rate of 30 feet of bridge slab per hour for transverse screeding unless otherwise shown on the plans. Deposit concrete parallel to the skew of the bridge so all girders are loaded uniformly along their length. Deposit slab concrete between the exterior beam and adjacent beam before placing concrete in the overhang portion of the slab. Furnish personnel and equipment capable of placing, finishing, and curing the slab at an acceptable rate to ensure compliance with the specifications. Place concrete in transverse strips. Start placement at the lowest end on profile grades greater than 1.5%. At the contractor's option, attach a pan drag and either a carpet or burlap drag to the screed assembly to float and provide surface microtexture in one operation. Adjust the contact pressure of the pan drag to smooth high spots and fill any depressions left by the screed. Adjust the weight or position of the carpet or burlap drag to produce a smooth sandy microtexture without blemishes, marks, or scratches deeper than 1/16 inches. Fill screed rail support holes and holes from the engineer's depth checks for slab thickness and reinforcing cover with concrete, and finish them to match the rest of the slab. 4.6.13.2 Longitudinal screeding. Use of temporary intermediate headers will be permitted for placements over 50 feet long if the rate of placement is rapid enough to prevent a cold joint and if these headers are designed for easy removal to permit satisfactory consolidation and finish of the concrete at their locations unless otherwise shown on the plans. Deposit slab concrete between the exterior beam and the adjacent beam before placing concrete in the overhang portion of the slab. Place concrete in longitudinal strips starting at a point in the center of the segment adjacent to one side except as the section indicates, and complete the strip by placing uniformly in both directions toward the ends. Start placing at the lowest end for spans on a profile grade of 1.5% or more. Use strips wide enough that the concrete within each strip remains plastic until placement of the adjacent strip. Place the concrete in proper sequence to be monolithic with the adjacent longitudinal strips of the slabs where monolithic curb construction is specified. 4.6.13.3 Placements on continuous steel units. Place slabs on continuous steel units in a single, continuous operation without transverse construction joints using a self-propelled transverse finishing machine or a mechanical longitudinal screed unless otherwise shown on the plans. Retard the initial set of the concrete sufficiently to ensure concrete remains plastic in at least 3 spans immediately preceding the slab being placed. Use construction joints, when required for slab placements on steel beams or girders, as shown on the plans. Ensure the previously placed concrete attains a compressive strength of 3000 psi when staged placement of a slab is required on the plans before placing the next stage concrete. Multiple stages may be placed in a single day if approved. Use an approved placing sequence that will not overstress any of the supporting members where plans permit staged placing without specifying a particular order of placement. 4.6.13.4 Slab and girder units. Place girders, slab, curbs of slab, and girder spans monolithically unless otherwise shown on the plans. Fill concrete girder stems first, and place the slab concrete within the time limits specified in this item. Place concrete in the stems for a short distance if using a transverse screed, and then place the concrete in transverse strips. Fill the outside girder stem first, beginning at the low end or side, if using a longitudinal screed, and continue placement in longitudinal strips. 4.7 Finish and interim curing of bridge slabs. Obtain approval of the proposed interim curing methods, equipment, and materials at the pre-pour meeting before placing concrete. Take into account forecast weather conditions to determine the interim curing methods to use. Use work bridges or other suitable facilities to perform all finishing operations and to provide access, if necessary, for the engineer to check measurements for slab thickness and reinforcement cover. Work the screeded surface to a smooth finish with a long-handled wood or metal float or hand-floated from work bridges over the slab. Floating may not be necessary if the pan float attached to a transverse screed produces an acceptable finish. Avoid overworking the surface of the concrete. Avoid use of finish water. Perform sufficient checks, witnessed by the engineer, with a long-handled 10 feet straight edge on the plastic concrete to ensure the final surface will be within specified tolerances. Make the check with the straight edge parallel to the center line. Lap each pass half over the preceding pass. Remove all high spots, and fill and float all depressions over 1/16 inches deep with fresh concrete. Continue checking and floating until the surface is true to grade and free of depressions, high spots, voids, or rough spots. Fill screed rail support holes with concrete, and finish them to match the top of the slab. Provide a uniform microtexture using a carpet drag, burlap drag, or broom finish. Finish the surface to a smooth sandy texture without blemishes, marks, or scratches deeper than 1/16 inches. Apply the surface texturing using a work bridge or platform immediately after completing the straight edge checks. Draw the carpet or burlap drag longitudinally along the concrete surface, adjusting the surface contact area or pressure to provide a satisfactory coarsely textured surface. A broom finish may be performed using a fine bristle broom transversely. For bridge approach slabs, the carpet drag, burlap drag, or broom finish may be applied either longitudinally or transversely. Evaporation protection is required if the evaporation rate exceeds 0.10 pounds/SF/hours based on the evaporation calculation for concrete worksheet as shown on the department's website, the evaporation rate nomograph in the Portland Cement Association's design and control of concrete mixtures, or if indicated on the plans. 4.7.1 Evaporation protection. Use one of the following methods for evaporation protection. 4.7.1.1 Evaporation retardant. Coat the concrete surface immediately after the carpet or burlap drag, or broom finish with a single application of evaporation retardant at a rate recommended by the manufacturer. Do not allow more than 10 minutes to elapse between the texturing at any location and application of evaporation retardant. The evaporation retardant may be applied using the same work bridge used for surface texturing. Do not work the concrete surface once the evaporation retardant has been applied. 4.7.1.2 Wet burlap. Place pre-wet burlap no more than 10 feet behind the finishing operation. A work bridge may be required to avoid marring the surface. Ensure the wet burlap covers the entire surface. Use sprayers, hoses, sprinklers, or other similar methods to keep the burlap continuously wetted until application of the final curing. 4.7.2 Interim Curing. Apply interim curing using one of the following options after applying the evaporation protection, if needed. 4.7.2.1 Membrane Cure. Apply membrane interim curing at a rate of approximately 180 square feet per gallon. Apply before the water sheen disappears, but do not place over standing water. Fog as necessary to maintain the wet sheen. Do not spray membrane curing on a dry surface. 4.7.2.2 Wet burlap. Place pre-wet burlap no more than 10 feet behind the finishing operation. Burlap used for evaporation protection will also be considered as the interim curing. 4.8 Final curing. Obtain approval of the proposed curing methods, equipment, and materials at the pre-pour meeting before placing concrete. Inadequate curing or facilities may delay all concrete placements on the job until remedial action is taken. Apply final curing as soon as possible after interim curing without damaging the surface finish. Check the adequacy of the curing each day of the curing period. Take corrective action or modify the curing methods as needed to maintain a moist concrete surface. A curing day is a calendar day when the temperature, taken in the shade away from artificial heat, is above 50 degrees Fahrenheit for at least 19 hours, or, on colder days, if the temperature of all surfaces of the concrete is maintained above 40 degrees Fahrenheit, for the entire 24 hours. The required curing period begins when all concrete has attained its initial set. TxDOT 440A may be used to determine when the concrete has attained its initial set. Cure all superstructure concrete according to the following, unless otherwise shown on the plans. Concrete using type 1 or 3 cement, 8 days. Concrete using type 1 and 2 or 1 cement, 10 days. Concrete with any type of SCM, 10 days. Place polyethylene sheeting, burlap polyethylene blankets, laminated mats, or insulating curing mats in direct contact with the slab when the air temperature is expected to drop below 40 degrees Fahrenheit during the first 72 hours of the curing period. Weigh down these curing materials with dry mats to maintain direct contact with the concrete and provide insulation against cold weather. Supplemental heating or insulation may be required in cold and wet weather if the insulating cotton mats become wet or the concrete drops below the specified curing temperature. Avoid applying heat directly to concrete surfaces. Use one of the following water curing methods for final curing. Keep all exposed surfaces of the concrete wet continuously for the required curing time. Use water for curing that meets the requirements for concrete mixing water in section 421.2.5, water. Do not use seawater or water that stains or leaves an unsightly residue. 4.8.1 Cotton mats. Keep the concrete continuously wet by maintaining wet cotton mats in direct contact with the concrete for the required curing time. Weight the mats adequately to provide continuous contact with all concrete. Cover surfaces that cannot be cured by direct contact with mats, forming an enclosure well anchored to the forms or ground so outside air cannot enter the enclosure. Provide sufficient moisture inside the enclosure to keep all surfaces of the concrete wet. Use of soaker hoses and plastic covering is acceptable provided the concrete surface remains continuously wet for the required curing duration. 4.8.2 Burlap mats. The burlap used for interim curing may also be used for final curing if kept continuously wetted and completely covered with plastic sheeting. Overlap plastic sheeting and weigh down sufficiently so air cannot get under the plastic. 4.8.3 Burlap polyethylene mats. Place these mats over soaker hoses or other similar methods to keep the concrete surface wetted for the duration of the curing period. Overlap the mats and weight down sufficiently so air cannot get under the mats. 4.9 Removal of forms and false work. Forms for vertical surfaces may be removed after the concrete has aged 12 hours after initial set provided the removal can be done without damage to the concrete unless otherwise directed. Remove forms for inside curb faces and for bridge rails whenever removal can be done without damage to the curb or railing. Leave in place weight supporting forms and false work spanning more than 1 feet except as directed otherwise until the concrete has attained a compressive strength of 2,500 psi. Remove forms for other structural components as necessary. Forms or parts of forms may be removed only if constructed to permit removal without disturbing forms or false work required to be left in place for a longer period on other portions of the structure. Remove all metal appliances used inside forms for alignment to a depth of at least 1/2 inches from the concrete surface. Make the appliances so that metal may be removed without undue chipping or spalling of the concrete, and so that it leaves a smooth opening in the concrete surface when removed. Do not burn off rods, bolts, or ties. Remove all forms and false work unless otherwise directed. Apply an ordinary surface finish as the final finish to the bottom of bridge slabs between girders or beams, and vertical and bottom surfaces of interior concrete beams or girders unless otherwise noted. Form marks and chamfer edges do not need to be smoothed for the bottom of bridge slabs between girders or beams. Remove all fins, runs, drips, or mortar from surfaces that will be exposed. 4.10 Defective work. The contractor is responsible for the ride quality of the finished bridge slab. The engineer will use a 10 feet straight edge, 1/8 inches in 10 feet, to verify ride quality and determine locations where corrections are needed. Submit a plan for approval to produce a ride of acceptable quality if the engineer determines the ride quality is unacceptable. Make all corrections for ride before saw cutting grooves. Repair defective work as soon as possible. Remove and replace at the expense of the contractor any defect that cannot be repaired to the satisfaction of the engineer. The engineer will inspect the deck or slab for plastic shrinkage and settlement cracking after completion of final curing and within 5 days after curing mats are removed. Seal any noted shrinkage cracks attributable to contractor placing, curing, and finishing practices using gravity feed crack repair as directed in accordance with item 780. Concrete crack repair, at no cost to the department. Transverse cracks over interior vents in continuous slab units do not need to be sealed in this manner. 4.11 Final surface texture. Saw cut grooves in the hardened concrete of bridge slabs, bridge approach slabs, and direct traffic culverts to produce the final texturing after completion of the required curing period unless otherwise noted. Cut grooves perpendicular to the structure center line. Cut grooves across the slab within 18 inches of the barrier rail, curb, or median divider. Adjust groove cutting at skewed metal expansion joints in bridge slabs by using narrow width cutting heads so all grooves end within 6 inches of the joint, measured perpendicular to the center line of the metal joint. Leave no ungrooved surface wider than 6 inches adjacent to either side of the joint. Ensure the minimum distance to the first groove, measured perpendicular to the edge of the concrete joint or from the junction between the concrete and the metal leg of the joint, is 1 inch. Cut grooves continuously across construction joints or other joints in the concrete less than 1/2 inches wide. Apply the same procedure described above where barrier rails, curbs, or median dividers are not parallel to the structure center line to maintain the 18 inches maximum dimension from the end of the grooves to the gutter line. Cut grooves continuously across formed concrete joints. Provide either a carpet drag or broom finish for micro texture when saw cut grooves are not required on the plans. In this case, ensure an adequate and consistent micro texture is achieved by applying enough weight to the carpet and keeping the carpet or broom from getting plugged with grout. For surfaces that do not have adequate texture, the engineer may require corrective action including diamond grinding or shot blasting. Give a carpet drag, burlap drag, or broom finish to all concrete surfaces to be overlaid when the plans call for a concrete overlay, (CO), to be placed on the slab, new construction. Saw grooving is not required in this case. Provide an average texture depth for the finish of approximately 0.035 inches with no individual test falling below 0.020 inches, unless otherwise shown on the plans. When tested in accordance with TEX 436A, revise finishing procedures to produce the desired texture if the texture depth falls below what is intended. Give all concrete surfaces to be covered a lightly textured broom or carpet drag finish when the plans require an asphalt seal, with or without overlay, on the slab. New construction. Provide an average texture depth of approximately 0.025 inches when tested in accordance with TEX 436A. 5. Measurement. Reinforced concrete slabs or decks on girders, beams, slab beams, double T beams, or box beams placed under this item will be measured by the square foot of slab surface area using the nominal dimensions and configuration shown on the plans. Transverse measurement will be made from outer edge of slab to outer edge of slab, including raised median and sidewalk sections. Longitudinal measurement will be made between ends of units or spans. Diaphragms, haunch concrete, reinforcement, and optional steel diaphragms will be considered as a portion of the slab unless otherwise shown. An estimated quantity for the haunch between the slab and beams will be included for the contractor's information only. No measurement will be made during construction for variation in the amount of haunch concrete due to variations in camber of the beams. Approach slabs and cast-in-place superstructure elements including flat slabs, slab and girder units, pan-formed, and shear keys will be measured by the cubic yard. For slab and girder spans using pan forms, a quantity will be included for the screed setting required to provide proper camber in the roadway surface after form removal. This is a plan's quantity measurement item. The quantity to be paid is the quantity shown in the proposal unless modified by Article 9.2, Plans Quantity Measurement. Additional measurements or calculations will be made if adjustment of quantities is required. The quantities of concrete and reinforcing steel shown on the plans are based on a conventionally formed slab. These quantities include amounts for concrete diaphragms, brackets, and other required attachments, and haunch concrete when required, based on the profile grade, theoretical camber, and dead load deflection of the beams. No additional measurement will be made for concrete or reinforcing steel due to a variation in camber of the beams from theoretical camber, or for additional quantities required by optional methods of forming. Additional concrete that may be required by an adjustment of the profile grade line during construction, to ensure proper slab thickness, will not be measured for payment. 6. Payment. The work performed and materials furnished in accordance with this item and measured as provided under measurement will be paid for at the unit price bid for the various superstructure elements specified. This price is full compensation for furnishing, hauling, mixing, placing, curing, and finishing concrete, furnishing and placing reinforcing steel, grouting and pointing, furnishing and placing drains and expansion joint material, except where specifically furnished under another item, furnishing and placing metal flashing strips, forms, removable and permanent, and false work, pressed rest concrete panels, furnishing and placing concrete and reinforcement for raised medians, sidewalks, sign mounts, luminaire brackets, and other concrete appurtenances, removing designated portions of existing slab, cleaning, bending, and cutting exposed existing reinforcing steel, welding reinforcing steel, doweling, cleaning and preparing concrete surfaces, and equipment, labor, tools, and incidentals. Price will be adjusted in accordance with Section 421.6, Measurement and Payment, when required to address non-compliance of project acceptance testing. Diaphragm concrete will not be paid for directly but is subsidiary to the slab unless otherwise shown on the plans. Structural steel, anchor bolts, armor joints, sealed expansion joints, rail, including the concrete parapet portion, and concrete median barrier will be measured and paid for in accordance with pertinent bid items. In addition to the work described above, for extending structures the unit prices bid is full compensation for removing and disposing of the designated portion of the existing structure, removing, stockpiling and replacing head wall units for reuse, cleaning, bending, and cutting of exposed reinforcing steel, splicing or welding of new reinforcing steel to existing reinforcing steel, installation of dowels, and cleaning and preparing existing concrete surfaces.